Okay, I'm happy to be here today. This is a weird presentation format, so I'm going to do my best. I'll try and be visual. I came to the University of Washington 7 years ago with over 15 years of practice as an architect and structural engineer. And my research there has been focused on bringing the understanding the environmental impact of building materials and trying to bring that scientific understanding to design decision making. So what I'm going to talk about today is primarily related to the environmental impact of wood, and if I can figure out how to go forward. A brief overview of the work on a teaching front that's happening at the University of Washington. So as Todd mentioned, there's a growing excitement about the possibilities of wood construction that flows from our design studios, competitions. From 2013, Timber in the City, we had an honorable mention award, and another studio just ran this spring with another set of submissions to that competition. I've just co-taught an integrated design studio with architects, engineers, construction managers, and energy modelers. There we were looking at large commercial office buildings and the opportunities from a technical and aesthetic perspective. And that's overlapping, looking at things such as post-tensioning systems, composite systems. Students are doing research looking at cost, environment, and structural optimization. These are 2 master's thesis projects. So the bulk of what I want to talk to you about is research that's led through the Carbon Leadership Forum. This is a group of industry leaders looking to use environmental life cycle assessment to lead to low carbon buildings. The group does work such as co-authoring with the USGBC and Ceres climate declaration, so an opportunity for firms to come out forth and saying that climate change is an important opportunity and concern, so both a business case and an environmental case for moving forward. So this would be an action item if you were wanting to bring your firm to come together with national leaders and emphasize your commitment to climate change impacts. This is an opportunity. So embodied carbon, embodied emissions are less often the focus of understanding the environmental impacts of buildings, and that's primarily because there's a large focus on operational impacts. Okay, you can't really hear me, is that right? You can hear me? Now you can hear me. Okay. I'm not used to talking to music. So the large emphasis on operational impacts makes sense when you look at a total life cycle of in the 80-year time frame of a typical type of building. If you look at lower operational energy, so driving to zero net energy buildings, the embodied impacts become a larger percentage. Additionally, if we look at the Paris targets from reducing carbon emissions, they are very ambitious, and we need to be reducing carbon emissions in the 10 to 15-year time frame, not in the 80-year time frame of a building that's being built. And so that if you look at the quantities of buildings built in the near term, the relative proportions of their impacts of embodied impacts to operational impacts are flipped on the head because they haven't been operated very long. So if we're wanting to make dramatic impact now, we need to actively focus on the embodied impacts or the impacts related to the materials used in construction. If we look at typical buildings and the breakdown of where those embodied impacts occur, the largest percentage comes in structure and enclosure, and this is really where wood starts to tell an exciting story. Environmental life cycle assessment is a method of quantifying environmental impacts over the life cycle. Those environmental impacts are really related to emissions that can be tracked. So there are drivers to use of environmental life cycle assessment. LEED version 4, which will start in November, is giving credits for whole building life cycle assessment and using life cycle assessment to optimize product performance. And if we really, I think I'm just gonna go. So the most, I think the most important takeaway that I would like you to get from today's presentation is twofold. One is big picture. Wood is a really exciting, promising building material for low carbon construction. So in the wide range of research, that comes to be conclusive. On the other hand, environmental life cycle assessment does not track all environmental impacts. And so it does not deal with forest health or habitat loss or species protection. And so the use of life cycle assessment data can be controversial because some people see that by touting the carbon benefits of wood, you're trying to hide the other environmental impacts of forestry. And so I think it's important to pay attention to both of those impacts. If we're looking at taking the recognizing the benefits of carbon and wood, we need to recognize that our forests need to be managed healthily and sustainably on the long term. So there's a really complicated story about forests as a carbon sink. And I am not the full expert on this, but what I am the expert in is trying to understand it. And simply, what was said earlier is true. Trees are sinks. But not all the tree is used as a forest product. And there are roots and slash and a whole lot of other issues that need to be dealt with in terms of the carbon impacts. But you can even step away from the tree as a carbon sink to tell a compelling carbon story, because wood is a low carbon material to make, irregardless of whether or not it is sequestering carbon, because the sun is building the material. So if you can kind of step back from whether or not it's carbon negative, in terms of how much have you sequestered, and just look at the fact that the impacts are lower in terms of making materials. And so this is where I think the tricky confusion comes around wood when you're looking at carbon impacts of wood, because there are different reporting methods of reporting carbon in wood. One method, which would be the gray line that's showing here, would be tracking the carbon over time. So the horizontal axis is time and the vertical axis is carbon. So when you plant the tree, there's some carbon emissions related to moving around the truck and burning fossil fuels to plant trees and manage the planting of trees. Over time, you're absorbing carbon as the tree grows, and that at some point in time, if you harvest the tree, you're also then going into the positive, away from the negative into the positive, as you burn fossil fuels again to cut down trees and manufacture products. And over then the horizontal line during use is the sequestered time when the tree is held into a building. And the longer you can hold it into a building, that's good. So there's a whole lot of modeling that uses that assumption about how long things are held inside the product. And then at the end of life, you're either burning it, reusing it, or disposing of it, which all have different ways of releasing the carbon into the atmosphere after it is at its end of life. The red line at the top is just looking at the carbon emissions of manufacturing the product and not the amount related to sequestering. So some carbon emissions are reported as positive for wood products and some are negative for wood products, and it depends on whether or not how you're tracking that. So for the wood industry, always want to report the negative, right? Carbon sink, negative, carbon negative. And if you're the concrete or steel industry, you don't want to report that, right? Because it makes wood more negative, right? So and so the life cycle assessment can be a challenging effort of industries fighting against each other about trying to define whether or not it's negative or positive, or whether or not the trees are happy or not. But for me, the takeaway really comes in that the wood remains a lower carbon product to begin with, and there are appropriate uses for it, and there are less appropriate uses for it. So this is the results of studying a same building with switching out the structural system and trying different options. This is using the Athena Impact Estimator, which is just a free downloadable life cycle assessment tool, and testing about whether or not you could meet the LEED version 4 whole building LCA credit by building it out of wood. And the general conclusion is that using wood as an alternate to primary structural materials is a good method a reasonable method of likely meeting the LEED credits for whole building life cycle assessment. This is a range of studies of multiple different buildings, comparing switching wood out of those buildings. And so this is where you start to see the consistent story that when you're trading out wood, you have a tendency to reduce environmental impacts in a range of different studies, but not always. And you'll see that there are some, so everything below the 100% line is reduction from a conventional building baseline. In some cases, we're having results of higher environmental impacts other than global warming potential or climate change or carbon emissions, all the same thing. In ozone depletion is an environmental impact that has really been covered by, resolved by oh my gosh. We no longer have hairspray, and we no longer have, thank you, the removal of CFCs through international treaties. So that is not an area of significant concern in the building industry, and eutrophication is over-fertilization getting into waterways. So there are some issues related to wood products and certain types of manufacturing that may lead towards higher eutrophication. So I'm wanting to thank my sponsors and some of the research that's been funded by the U.S. Department of Agriculture related to understanding the environmental impact of commercial construction, wood buildings and commercial construction.